In the previous video, we saw how to define a procedure whose source contained a single for each command that accessed data from a base table and its extended table. Now, suppose that the travel agency has requested a list that shows all the tourist attraction categories, and for each category, all its attractions. Before meeting this requirement, we will run the application to add another category to the ones we had and a couple of tourist attractions. We press F5. And we add this category. And we associate the newly created category with the Great Wall of China. Also, we add Christ the Redeemer. And to the United States, we add the city Washington in order to add the Smithsonian Institute. Now we will start to create the list required. We create a new object of procedure type. So as not to start again from scratch, we save the one we had with another name. We delete the source content and change the layout. And we change the text inside this text block. We also add a print block to show the categories. Even if we can place it anywhere, because the printing order of the print blocks is given in the source, we will place it where we want it to be listed, so that it's easier for us to see how everything will be displayed at runtime. Categories is the name we give to this new print block. There we will insert a text block, category, and an attribute, category name. The other print blocks will remain unchanged. Note that we have two print blocks with fixed contents, title and column titles, and two print blocks with variable contents that will have to be extracted from the database, categories and attractions. Both of them contain attributes. Categories has category name from the category table, and attractions contains all these attributes that we had noticed belong to the attraction extended table. Now we move on to the source. We type the first instruction to print the list title just like we had done before. Since this print block doesn't contain attributes, it isn't necessary to look for data in the database, and we can print without doing anything else. Now let's see how to continue. We have to navigate categories, and for each one of them, navigate several attractions, the ones that belong to this category. For this reason, this list is different than the one we saw before. In the previous list, we navigated attractions, and since each attraction has only one country, we could retrieve the name of each attraction's country, because it was in the extended table of the base table that we were navigating. As long as the information we want to retrieve is available in the extended table of the base table we're navigating, we can reference it directly in the forEach command. That was the case of country name. On the other hand, if we're navigating a table, in our case category, and for each accessed record we need to navigate several related records, which are saved in another table that doesn't belong to the extended table of the table we're navigating or running through, as in this case, with the attraction table, we will need to write another forEach command inside the first one to run through the group of related records. That is to say, we will have a forEach command nested inside the other. We return to the source of our procedure and start to write the first forEach command to navigate and show categories. Next to the forEach command, we type category. Remember that here goes the base transaction. That is to say, the name of the transaction level whose information we want to navigate. What do we want to do first with each category accessed by the forEach command? print it. So, inside the for each command, we type print categories. Since the categories print block only includes the category name attribute, and GeneXus has inferred that the base table of the for each command is category, and category name is included in the extended table of this base table, because in this example, it's in the table itself, everything will be in the correct order and it'll be possible to retrieve the data. Otherwise, GeneXus would give an error. After printing the category, we want to navigate its group tourist attractions. Therefore, we need to type the second for each command to run through the n attractions of the category we're navigating. But right before navigating the group of attractions in that category, we will have to show the titles of the attractions that will be displayed. So we type the instruction print attractions column titles. Now we type the second for each command inside the body of the first one. Next, we type attraction because it's the name of the transaction whose associated table we want to navigate now. Inside the for each command, we type print attractions. Next, we type end4 to close this navigation. And end4 again to close the first one. Remember that to print the report in PDF format, we need to set the properties of the main program report to true. Call protocol as HTTP. Also, we need to insert the output file rule. Because we had saved the previous report with another name, all these settings had already been made. In this rule, we replace the PDF name with the new one. Now we save. And we run this list with F5. Note that all the categories that we had entered have been listed. And for each one of them, the attractions that belong to this category have also been listed. In this way, we've met the requirement made by the travel agency. How did GeneXus know which attractions had to be shown for each category if we didn't explicitly indicate anything about it? Let's take a look at the for each commands. We know that a for each command runs through n records in a table, and, for each one of them, runs a series of instructions. Inside the body of the first for each command, we will be positioned on a single category. We say that the category is instantiated every time, because it's a certain category. Only when the execution of the instructions in the body is completed, it moves on to the following category. Therefore, before starting to execute the nested for each command, GeneXus already knows the category in which it's positioned at that moment. That's why we wrote a for each command that navigates the attractions, without adding a where clause to filter those attractions, meeting the condition that their category must match the category we're positioned in within the first for each command. How did GeneXus determine that filter without us having to write it? The answer is in the way for each commands are written. If two for each commands are written one after the other, they are independent of each other. On the other hand, we type one for each command inside another for each command because for each record of the first navigation we want to run through a set of records in the second one. When we write nested for each commands, GeneXus determines, for every for each command, the base table that will be navigated, and then looks for relationships between that information. In our case, the base table of the external for each command is category, and the base table of the internal for each command is attraction. GeneXus knows that there's a common attribute between both tables. This common attribute is category ID, which is a primary key in category and foreign key in attraction. In this way, the category ID attribute relates the tables attraction and category, as we can see in the diagram, which establishes a 1-to-n relationship. That is to say, for every category, there are many related attractions. Therefore, for every category navigated in the external for each command, GeneXus runs the for each command that navigates the attractions table, filtering only those attractions whose category ID value matches the category ID value of the category we're positioned in. It's exactly as if in the internal for each command we had written where category ID equals category ID. But we don't have to type it because GeneXus detects it and applies it. If we open the navigation list of this procedure, we can see that it provides information about the two for each commands. The base table of the external one is category, and that of the nested one is attraction. In addition, we can see that categories are retrieved in the order specified by their identifier, category ID, and that attractions are also ordered by this attribute. But in this table, it's a foreign key. It is the attribute that relates them, and that's why we see in the navigation filters that only the attractions in this category will be retrieved. We've seen how easy it is to obtain information and display it in a report. But procedures can do much more than that. We will see that later on. Lastly, we update the changes in GeneXus server. As a review, let's remember that when we type nested for each commands, GeneXus determines, for every one of them, the base table that it will navigate, and looks for any relationship between these base tables. If the answer is yes, as we've seen in the list shown in this video, it'll apply an automatic filter to the records run through by the nested for each command. This case of nested for each commands, where information is filtered according to a relationship criterion, is called join. If, on the other hand, the answer to the question about the existence of a relationship was no, no filter would be applied. All the records of the nested for each command for every record of the external for each command would be printed. This type of nested for each command, where no implicit relationship is found, is called Cartesian product. Of course, the developer can always add explicit filter conditions by typing them directly in the for each command with where clauses. In these cases, we assumed that the tables were different. In the following video, we will see what happens when the tables of the external and nested for each commands are the same table.